All right, so now we're going to pick up with another definition here of an angle bisector. We talked about a segment bisector a couple sections ago, so now we're going to look at angle bisector. So an angle bisector is a ray that divides an angle into two congruent angles. I don't know if you remember, but when we, let me go back. I don't know if you remember, but when we talked about segment bisectors, we talked about this word bisect. And I told you that forever and ever, when you think of bisect, you need to think of cut or split, right? Cut into two congruent parts, right? So in this case, an angle bisector cuts an angle into two congruent angles. This is very, 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 very important, right? Bisector gives you congruent things, and that's important. Okay, so in this picture here, angle XAZ is the big angle. Ray AY is your angle bisector. So notice here, congruent, congruent. These two angles are congruent. So it says, if ray AY is the angle bisector of angle AXZ, then angle AXY is congruent to angle YAZ. XAY is congruent to YAZ. Now I wanted to add a couple other statements here. So first off, if these two angles are congruent, then their measures are equal. So the measure of angle XAY will be equal to the measure of angle YAZ. But because these two angles together make the larger angle, and because they're congruent or have the same measure, then each of them is also half of the larger angle, angle XAZ. Similarly, right? The measure of the large angle, angle XAZ, is going to be 2 times each of those smaller angles. It'll be 2 times the measure of angle XAY. And it'll also be 2 times the measure of angle YAZ. So again, just a lot of relationships here coming off of an angle bisector. All right. Now, again, I'm going to use Desmos geometry to illustrate this idea. All right, so let's take a look here. Remember, you can always pause videos whenever you need to, right? All right, so let's go back to Desmos geometry. So I'm here. I'm going to create an angle using 2 rays. And I will label those 2 angles, and I'm just going to use, ABC. Sorry, I'm not going to use the, okay? And let's measure that angle. So angle ABC. So that's 63. For our benefit, because of the limitations, I want to make it an even number. So 64. Okay. So now I'm just going to kind of estimate where I think the middle is, put a point there, call that D, and I'm going to draw a ray BD. So now right now, I think that's the angle bisector. Again, I'm going to measure things and move it to make sure. But right now, can you tell me the measure of each of those angles? If BD is the angle bisector of angle ABC, well, you should be thinking, and I'll go to Desmos graphing calculator, 64 divided by 2, right? That's what you should think about. Each of those angles should be 32 degrees. So let's measure one. So let's measure angle ABD. And I got 29. Okay, I'm a little bit off. So I'm going to move D down. Remember, I don't move it along the side of the angle. It doesn't help. I'm going to move it down. And there's 32. So now if I measure the other angle, DBC, it should also be 32. Let's see. DBC. And again, limitations of the software, it says 33. Let me see if I can get it to be, there you go, 32 and 32. Perfect. So there's an example of an angle bisector. Okay. All right. So back at it here. So I'm going to do 2 more slides on this video. So we're going to talk about theorems now. So we're getting into the big boy and girl stuff. Theorems. Theorems are statements that you can prove true. I don't know if you've talked to any older friends, but there's this idea of proof in geometry. And I know some people are like, oh, I hate it. I will tell you that if you just have an open mind, I know a lot of students who, when we leave proofs, they say, oh man, I just got the hang of it. Why are we leaving it? So Don't knock it till you try it, kind of thing with these proofs. But here's our first theorem. And again, this is about vertical angles. Very, very, very important. It's called the vertical angles theorem. It says that vertical angles are congruent. And you might have thought about this when we talked about vertical angles a couple slides ago in the other video. So let's take a look here, right? So we have these two intersecting lines creating vertical angle pair 1 and 3. Remember that V left, V right, and 2 and 4, V up, V down. So angle 1 is an acute angle. It's going to have the same measure as angle 3. Angle 2 is an obtuse angle. It's going to have the same measure, notice the two arcs, as angle 4. Happens every time with vertical angles. Now let's go into Desmos geometry and let's try to show this or illustrate this. Okay. I like using Desmos geometry. I'm sorry if it makes the videos longer. So let me draw two lines, right? There we go. Let's call this line A, B. Let's call this line C, D. And let's put a point where they intersect, call that E. And I'm going to drag A to make it a little more drastic, right? These all look kind of the same, so and drag B. Okay, so I think obviously you see an obtuse pair and an acute pair. So let's just go ahead and measure, right? So let's measure angle A, E, C, 41 degrees. So I should know what angle DEB is. It's a vertical angle to angle AC. They should be congruent. DEB should also be 41 degrees. DEB. And look at that. Same thing if I measure the other pair. AED, 139. BEC should also be 139. Let's see. BEC. And look at that. Vertical angle pairs. They are congruent. Excellent. Okay, cool. So vertical angles, very important to our continuing on this class, especially when it comes to proofs. Okay. Now I want to talk about one more theorem on this video. It's called the congruent supplements theorem. It's on the next one. Here you go, congruent supplements theorem. It says if two angles are supplements of the same angle or of congruent angles, then the two angles are congruent. So let's look at the picture here. So it says that angle 1 and angle 3 are supplements. That means they add up to 180. And it says that angle 2 and angle 3 are supplements. So now 2 and 3 add up to 180. Well, look at angles 1 and 2. Don't angle 1 and 2 look the same? Yes, they are the same. They're congruent. So angle 1 and angle 2 would be congruent. So let's just talk about this on this page right here. Let's say that angle 3 has a measure of 100 and let's say 30 degrees. If angle 1 and angle 3 are supplements, what does angle 1 have to be? Well, angle 1 has to be 180 minus 130, which is 50 degrees. Angle 1 has to be 50 degrees. Has to be. Well, let's look at angle 2 and angle 3. What if angle 2 and angle 3 are supplements? Well, if angle 3 is 130, then angle 2 must be 180 minus 130. That's 50 degrees. Angle 2 must be 50 degrees. Oh, look. Angle 1 and angle 2 have the same measure, 50 degrees. They are congruent. Should make sense to you. Okay, very simple. All right, great. So that's the end of this video. One more video for these notes.